Hello everyone and welcome to the channel Ideastic Station. If you haven't subscribed the channel yet, then go and subscribe the channel and press the bell icon to never miss an update. Now coming to the point, have you ever thought about traveling to space with a constant acceleration? If not, then I will give you full information on this topic. Firstly, there could be a question in your mind that why constant acceleration is proposed aspect for most of the future forms of space travel. Its answer is quite simple. That is, it entails that the propulsion system of whatever kind operate continuously with a steady acceleration rather than the brief impulsive thrust used by chemical rockets for the first half of the journey. It constantly pushes the spacecraft towards its destination, and for the last half of the journey it constantly uses back thrust so that the spaceship arrives at the destination at a standstill. It is notable for several reasons. Firstly, it is a fast form of travel when ergonomics are considered. They are the fastest form of interplanetary and interstellar traveler. Secondly, constant acceleration creates its own artificial gravity to the benefit of the passengers who may be spared from having to deal with the effects of microgravity. You could have got confused in constant thrust and constant acceleration, so let me clarify you. Constant thrust and constant acceleration trajectory phase involve the spacecraft firing its engine in a prolonged constant burn. In the limiting case, where the vehicle acceleration is highly compared to the local gravitational acceleration, the orbit approaches a straight line. The spacecraft points straight toward the target, that is accounting for target motion, and remains target in accelerating constantly under high thrust until it reaches its target. If it is required that the spacecraft rendezvous with the target rather than performing a flyby, then the spacecraft must flip its orientation halfway through the journey and deaccelerate the rest of the way. In the constant thrust trajectory, the vehicle's acceleration increases during thrusting period since the fuel use means the vehicle mass decrease. If instead of constant thrust, the vehicle has constant acceleration, then the engine thrust may decrease during the trajectory. Now I am going to deal on interstellar traveler. Over interstellar distances, a spaceship using significant constant acceleration will approach the speed of light, so special relativity effects become important. Here, relativity effects means the difference in the time flow between the ship time and planetary time, as you can see in the picture. So see it carefully. Now talking on its feasibility, a major limiting factor for constant acceleration drives is having enough fuel. Imagine a horse strong enough to pull a wagon carrying enough hay to feed it on a journey from New York City to Switzerland. Here constant acceleration won't be feasible unless the specific impulse for fuel becomes much higher. There are two broad categories for ways to solve this problem. One is higher efficiency fuel and other is drawing propulsion energy from the environment as the ship passes through it. Two possibilities for the motor ship approach are nuclear and matter animator based fuels. One possibility for the sailing ship approach as discovering something equivalent to the parallelogram of force between wind and water, which allowed sails to propel a sailing ship. There is a big issue of ships using constant acceleration for interstellar travel, that is, colliding with the matter and radiation while en route. In the mid-journey, any matter the ship strikes will be impacting at the near light speed, so the impact will be dramatic. So thanks for the watching. Bye.